This tutorial is exercise 18. Now to start off, open up the exercise 18 PDF file and the tolerance stack calculator. So what we're going to do in this tutorial is another tolerance stack calculation, and what I want to show you in this one is how to kind of manipulate your parts afterwards to make sure that you get your satisfaction for your design. In this case, what we're doing is we're going to have a bolt, a couple washers, two pieces of material that we're kind of clamping together, and our nut. And what we want is that we need to have at least 3 millimeters of the bolt thread protruding out. So what we're going to do with this is that our washers and our nut, we're able to play around with the tolerances and the thicknesses to get this desired condition. And what we're going to look at is the lower limit of our RSS. We want at least to be 3 millimeter. We're not going to worry about the hard stack. Okay, so let's start putting in our features. Our first one is the bolt, and it's going to be 50 mil with a tolerance of 0.5. Then we have the washers. We have two of them, and they're going to be 0.5 mil, tolerance is 0.1. Then we have our material. We're going to have two pieces at 20 mil with a 0.3. Then we're going to have our nut, just one at 5 mil and 0.5 mil. Now you can see we have a clearance in both cases. Our RSS and our hard stack, with the lower limits, the hard stack we have at least 2.2 mil at the worst case scenario of the bolt thread protruding out, and with the RSS we're at 3.16. So already we're very, very close to our desired condition. Now what this allows you to do though is that when you're sourcing out parts, obviously if you get a part that is that has a tolerance which is larger, it costs less money rather than a tolerance that is tighter. So if you know that you need at least that your design condition is 3 mil and the RSS is what you're using as your gauge, we still have 0.16 tolerance with our RSS lower limit to go either way. So with the washer, let's increase the tolerance to 0.2, and you can see that we go down a bit. With the nut, let's increase it to 1. Now it goes too far. We're at 2.77. Let's say we get a nut at 0.7. Now we're at 3 perfectly. Now what this does though is, like I said, you're able to kind of source parts out differently. So to begin with, I had a washer at 0.1 tolerance and a nut at 0.5. Now I'm able to increase that tolerance to 0.2 and 0.7. By increasing that tolerance, we're reducing the cost of our parts. So this is just a way that if you have multiple suppliers that you're able to go from, if you have all their specs and their costs and everything, you're able to put everything together easily in this calculator just to make sure that you meet your design condition, and you're also able to optimize for the greatest